Hello, class. Hope you're doing well and you've recovered from the election hangover or whatever, if that is ailing you. I'm making this video a day early because I'm going to Chicago for a conference, and I thought I would just get this out of the way and just send it to you guys. This article I want to share with you is about carbon capture using a covalent organic framework. That's what the COF, covalent organic framework. So covalent means, corresponding. That includes sharing of electrons. Organic means carbon containing, and framework is just, you can look at this. You can look at this image here. You can see it's kind of like this, like, I don't want to say call it. I don't want to say nanotubes, but I guess those would be nanotubes. Has this kind of almost like, hollow sort of honeycomb structure. So not unlike what a catalytic converter looks like, as a matter of fact. So the idea is that carbon dioxide can go in here, and then it'll absorb, it'll chemi-absorb, meaning there's a chemical reaction and it forms carbonates and bicarbonates. It says here that it forms carbonates and bicarbonates. And what's nice about this is then you can take it and heat it up to just 60 degrees Celsius, and then I think it's 60 degrees Celsius. Yeah. Heating the framework to 60 degrees Celsius release the captured carbon dioxide. So that's not a lot of energy. 60 degrees Celsius, that's not very hot at all, right? That's below boiling water. This is and they say this is for carbon capture from the environment, and for as a greenhouse gas. I think this is a great discovery because I think it has implications in other things. We do carbon capture and other things. If you've ever been aboard a nuclear submarine, they use a compound called monoethanolamine, and they use that to get carbon dioxide in the air. So in a nuclear sub, you're, of course, underneath the water. So they use electricity to crack water into hydrogen and oxygen. They dump the hydrogen, and then they put it in the oxygen to have the sailors breathe. And also, of course, when sailors, they breathe in oxygen, breathe out carbon dioxide. At a certain level, carbon dioxide starts to become toxic. So they have to scrub the air to strip out the carbon dioxide. And like I said, they use the monoethanolamine to do that, and that stuff stinks. It smells a lot like fish. So that's one thing about MEA. Some of the nuclear submariners or submariners, I don't know how you would pronounce it. They've mentioned the smell of that, and some people actually love it. So I don't know. I guess I had a student tell me that she loved the smell because it reminded her of her father. So I guess that's one interesting thing about humans and smell is that it's the closest sense to memory. It just brings us right to our memories with the smells. Anyways, where I was thinking this technology could go is two things. I mean, already obviously nuclear sub is one, although we do have a proven technology with that. One could be economical for carbon dioxide because we use carbon dioxide for various things, for making soft drinks, for putting carbon dioxide in various beverages as well. We also use it for oil. It's called tertiary recovery. You can pump down liquid CO2, and that pushes out more oil. It's a way to get more oil out of things. So this is, 6 degrees Celsius. That's not very, very high temperature. So we could take carbon and then use it for other things. Where I was kind of thinking this would go actually is space travel. So that's just like in a nuclear sub. You have carbon dioxide that the astronauts are generating, and you have to get rid of it. This could be a part of the CO2 scrubbing recovery, and maybe they'll even better if they found a way to convert CO2 back into oxygen. If there's a way to do that, so and then maybe do the carbon with something else. I know plants do it via photosynthesis, but it would be interesting to see if they could have something else, something synthetic that can do this. So, and what's also nice about this with space travel is it's like the proven technology, as I mentioned, is monoethanolamine, and it's a liquid, and having that system, if the liquid comes into the container, like the whatever you want to call it, the living area of the spacecraft, that can be a problem. If there's a leak, I mean, if something happens where like a micrometeor strikes the container that contains the monoethanolamine, it'll just evaporate into space, and I mean, then you're gonna lose then the passengers of the spacecraft are gonna die if that happens. I mean, so it's just a matter of time before they die. Unfortunately, with that, but this is, I mean, instead now you have something in the solid phase, right? So it's going to be less susceptible to things, and you don't have to, and it'd be easier to work with in zero gravity. So versus using a liquid, because to do that without well, the proven technology probably have to spin the spacecraft or something to get some artificial gravity going to say that way that the liquid could work better. There's a lot of things in space that behave differently than on Earth. Flames are one of them. Flames, they have more of a spherical shape than the flames that kind of, have the sort of more vertical prolate kind of dancing shape, kind of that we're familiar with, like candles and fire. Flames tend to be more spherical, and they don't really dance like they do in here on Earth. So a lot of chemical reactions behave differently, and also same with that physical processes. So this is one that would be an amazing application for its use in outer space. So I think this is cool. And I think it's going to have some unexpected benefits. So maybe as exotic as space travel, maybe as simple as carbon capture for economic purposes, not necessarily for greenhouse gases as it's intended, but it has other applications. So that's kind of cool. Aforementioned, I know, so that you might feel a little down from the election, or maybe you're elated. It's whatever. I mean, I hope you're happy. I mean, I always hope you're happy. If you're not happy, if you're having a hard time with things, feel free to reach out. I'll do what I can to help you out. If you're also having issues with basic needs, not getting enough to eat, not getting or having housing insecurities, let me know. If you're having academic problems, we're coming to the end of the course. I mean, we're not quite there yet, but we're past the halfway mark. So it's knocking on the door here. So also, I think I was thinking about sending this out tomorrow, but I think I'll send this out today. My flight leaves at 6 p.m., so I know a lot of people like to write me at night, and we got some deadlines coming up. I won't be able to respond until tomorrow, because I'll be in the airplane if you email me tonight. And I usually don't sleep on airplanes, so I'm probably going to have jet lag when I do get to Chicago. So, but we'll see. I should have some time to respond to emails though, so don't worry. I'm not gonna forget you guys. So, but I hope you're doing well, and if you need anything, let me know. So, aloha.